Oh, Jake. I was thinking Jake. 100 is M. This is B, this is M, this is your X. Yeah. Yeah.
Mike. Because I thought I could trust her. Oh, you said AK boys. See, exactly. I know what
yeah, it tastes like nothing.
So like gluten free or something?
What?
Gluten free or something?
I don't even know. It was like called apple crisp, and it tastes like just like dough.
It's disappointing.
I thought about it. I know. I love eating all the good things.
Alright, I want you to do this. This is like your warm up. Kind of review from yesterday. And take out when I told you I checked your homework. You're supposed to do the front and back of that packet I gave you yesterday. Cover out and judge you. Forgot. You got your work? You got your homework? Just front and back. You did like, you got a little carried away.
I did the front and then this.
I meant like the outside covers. Yeah, I can see how you would think about it. That's what I meant, yeah. Thank you, very good. You got it? Remember last year in integrated math, I used to feel bad for Nathan. Because it was like a lower, like, you were the smartest person in there, I think, by a pretty decent amount. And I was like, oh, he does his work, he's a smart kid. And then this year I'm like, oh, he doesn't do his work. I don't feel bad anymore.
I did it.
Thank you. I'm not calling you dumb. I'm just calling you lazy. Will it get better after football? A lot of people get worse. You just have the time. So there's some kids that only are passing classes so they're eligible for football. And then as soon as football, like, they have like a 60 and they're like, yeah, this is me trying. Like, wait till football's over. Great. It's a lot of time. What's the date? 18? Y equals mx plus b. The constant is your b. This one is your m. This is your x variable. It's zoomed in, so I can't. I was going to write the answers, but I can't.
Why wouldn't it just zoom in the marker too?
I think it just gets confused. If I zoom this all the way to normal, you guys can't really see that anymore, can you? Yeah. How many are still working?
My handwriting has gotten worse this year.
Sorry, David, you're just going to have to listen.
I'm actually cool. No, I can review it.
You sound like a party or some shit.
Have you seen that Vine? That was fast. I'm surprised she didn't say anything back.
What did she?
She was like, be quiet. It's like, I need to communicate to Laura.
Who's the parable?
She said, be quiet when someone was showing me. She was like, shh.
Who's the parable? There we go. Is she older than Porter? Oh, wait, nobody can do it. He's 60. 60. Oh, well, I think Porter's like 60 something. That's what he said last year.
60 something. He's told me before, but I forgot. I can't remember numbers that big.
He said it last year.
It's like 5 digits or something. Alright, let's look at these. So remember that when they give you this computer program printout, which I don't know why they chose this one, but they did, so that's what we use. This number is, so you always got your y equals mx plus b. That's your constant, that's your b. This is your m. Sorry, so this is your b, this is your m, and this is telling you, like, hey, the x variable is waste. And then this one actually, like, you could read through the problem, but this was kind of nice. It told you dependent variable is percent body fat. So you could have gone like, okay, percent body fat predicted, right, equals 1.7 times waste minus 42.734. Or you could have done the y equals mx plus b, and off to the side been like, hey, y is percent body fat, and x is waste. Questions on it? Alright, B, interpret R squared. So we don't use the, oh, they didn't give it to you. Sometimes they'll give you an R squared adjusted. Don't use the R squared adjusted, just use regular R squared. But this one didn't. So you would say 67.8%. What's the key phrase you gotta have? Variation in the data. Can be explained. And so we need context, right? By, you can put the regression line, you can put LSRL, and then you just put the variables on body fat and waist. All right, calculate and interpret the correlation coefficient R. So if I have R squared, what do I do to get to R? I square root it. Remember there are two square roots. So it's going to be either positive or negative 0.82. Am I choosing the positive or am I choosing the negative? I'm choosing the positive in this case. Why? Because the slope is positive. So your R and your slope have to have the same sign. So if the slope is negative, you would choose the negative one. And then to interpret this, so there is a strong, moderate, or weak. I'll say strong, positive. We can't technically tell if it's linear because we don't have a graph, but if you wrote linear, it's not the end of the world. So I'll put like in parentheses linear relationship. And what else do I need? The context. So between, do I have to keep writing? Okay. Questions on that? All right, do this. So let's say there's a part D. Predict percent body fat for a waist of, I don't know, 34. Try part D there. Predict percent body fat for a waist of 34. Many years ago. 34. Like 34 years ago.
It says 240 degrees of freedom. Why are you looking at these things? See how it says
It's not even that
240?
one. It's not even that fucking.
See, it says what?
248 degrees of freedom.
Yeah.
What if we measure that at a temperature like that?
It's
I don't understand.
Ignore.
I like that. Alright, so all you're doing here, I'm just making sure you understand what this, we're going to get more into this tomorrow, but making sure you understand what this does. This line predicts. Like this equation tells us what we'd expect, tells us the prediction. So I just plugged 34 in for waist. So the predicted body fat would be 1.7 times 34 minus 42.734. And I got like 15. How many had 15? Yeah, it's point something. Okay.
You know what? I'm sick of you.
Ah. Write that down. Draw that.
No, grab it. Come on.
Stop talking, draw. Plot, draw, sketch, etc.
All of the spots have to be exactly the same speed. Yeah, I think it's okay.
You got that sketched? Well, then write these down too. Did you see these inside? What I'm going to do is put a new point on there somewhere, and we're going to talk about what would happen to all four of those things. So if I put a point like way off to the side, what would happen to those? Alright, so if I put, and I'm not quite sure how you want to do this in your notes, but if I put a new point down here, let's call that A. That is an outlier in which direction? Is that like an unusual X value or an unusual Y value? It's an outlier in the Y direction. And then I'm going to sketch what would happen to your regression line. This gets kind of hard for you in your notes, I suppose. You might have to draw this like every time you do one. But if I were to put this point on here, what would happen to the regression line is not much. It would kind of go like this. Like that would be a very, very minimal change because the regression line responds very strongly to points on the ends. So if you put something on like over here, it's going to really start tipping based on those. If you put something in the middle, just high or low, it doesn't really do much. So for point A, your slope would not change and your y-intercept would barely change. So no change. Barely change. R and R squared are a little different though. So I put that point further away from the line. So does that make the relationship stronger or weaker? I made it weaker, so does that get closer to 1 and -1 or closer to 0? Closer to 0. So it's weaker, closer to 0. And if I made the relationship weaker, does R squared get bigger or smaller? So if the number got closer to 0 and I square it, it's going to get smaller. So R squared will go down. So I'm going to do that again. I'm going to do this like 5 or 6 times. I'll put another point on there and answer these questions. So if you want to, I don't know if you want to graph it yourself 5 or 6 times or how you want to handle it. I'm just telling you what's coming. So let's say I put a point way up there. Again, outlier in the y direction. You get what I'm saying? We're going to do this with like 6 different points. If you want some time to like sketch that scatter plot 6 times. You got a game plan already? So, but I'm taking the point A off. That's not there anymore. Okay. So that's just the opposite. The regression line would like barely move up. So your slope does not change. Your y-intercept would like barely increase. Would your R increase or decrease? Well, increase or decrease isn't the right way because it's negative, so it's a little weird. Would R get stronger or weaker? It'd be weaker, so it'd be closer to 0, so it actually increase. That makes sense. So we have a negative R right now. So if I make it weaker, it gets closer to 0, which actually makes it bigger. So weaker, closer to 0, and R squared would decrease. Questions there? Okay. Let's say I put a point right there. C. That's not an outlier at all. That's like right smack dab in the middle, right where it's supposed to be. It's basically perfect. Did you just make your relationship? Well, first of all, what happens to your slope and y-intercept? It'd be the exact same. Nothing. I mean, the new line would be that. It would just be like a little stronger now because you put a point right in the middle. So what happens to your R? Stronger or weaker? Stronger. So closer to, well, not 1 in this case. Closer to -1 or 1, depending if it's positive or negative. And R squared, bigger or smaller? Increase or bigger? Questions on anything yet? Yeah.
Is there gonna be a time where like R would get stronger and then like R squared would decrease?
that's an outlier in the x direction. That is called an influential point. Because it's an outlier in the x direction. So that point becomes important, and the line really like gravitates toward anything like on the outsides that has a really strong influence. So your new line would really take that into account, and it would probably look a little more like that. It has a pretty strong pull. Those endpoints have a strong pull. So let's look at what happens to these then. R stronger or weaker? Weaker because it's far away. R squared? Weaker. And then slope and y-intercept. So these always act opposites. If your slope goes, so if my elbow is the y-intercept, if my slope goes up, what has to happen to my y-intercept? Goes down. If my slope goes down, what has to happen to my y-intercept? Goes up. So they're always opposites. So if my slope was negative, now it's almost zero. Did my slope go up or down? Slope went up, and then the y-intercept used to be way up here, now it's here, so your y-intercept went down. Do you see what I'm getting at there? Does that make sense? Let's say I put a point here. Like here. What are we on? E? This is an outlier in the x direction, which is called what? An influential point. Because it influences the line. It's not like the most creative name ever. So again, because it's an outlier in the x direction, when you're on the endpoints, it really pulls the line toward that. It has a strong influence, influential point. So your new line would be probably something like that. And so R and R squared are the same idea. They both get weaker because you're like farther away from the line. And you actually just made a lot of these points farther away from the line too because you moved the line. What happened to your slope? Increase or decrease? Decrease. And then again, if your slope goes down, my left hand is the y-intercept. My slope goes down, what has to happen to my y-intercept? Has to go up. Let's do one more. Is this one okay? So let's say I put one, I made like a negative number, like way over here. So my x value is actually negative. I put a point here. So that's F. Tell me what kind of point it is and fill out those four things. Game plan work out, Ethan? Yep. Glad to hear it. So what kind of point is it? Influential point, because it has a strong influence. The name just kind of makes sense. So your new slope would be, your new line would probably look something like that. Stronger or weaker? Weaker, stronger or weaker? Weaker, increase or decrease? Actually increases, then decrease. Questions on that at all? Yeah, sorry. Should I not have erased it?
No, like, wouldn't R increase because it's like closer to zero? I mean.
So I said weaker. Weaker, I'm saying closer to zero. If we're at a negative number, I mean we make it weaker. It does actually increase. So we're saying the same thing. We're just like phrasing it differently, I think.
So it would be weaker.
Yeah, so like let's just do this. Let's say the R here was negative 0.8. And I put this new point over here. Here's your options for your new R. Would it be A or B? Anyway, it'd be B. So it gets weaker because it gets closer to 0. But it actually technically increased because negative 0.6 is bigger than negative 0.8. We on the same page? Okay. All right, got the packet from yesterday, please? And I believe I've tied everything on here, but just let me double check. Yeah, that's the only thing I haven't taught you. So one more thing. One more thing I want to show you. If I have, like let's take a look at, you don't even have to write this down if you just listen. This is not a hard thing. We did that graph of height and shoe size, right? So we had our data and it kind of looked something like this, and the smallest height in here was like 60 and the biggest was like 78. If I just look at like both classes. So sometimes they'll say, would it make sense to use this data to predict the height of someone who is 65 inches? Well, 65 falls right in between there. It's like it's exactly where we collected our data. 65 makes total sense. We can do that. What if I said, would it make sense to use this data to predict what shoe size someone that is 800 inches tall wears? Like this pattern exists here, but do I know what happens after that? It might start going way up. It might start going way down. It might like go flat. So you can't go beyond like the data set that you're looking at. That's called extrapolation. Like extra, you're going extra beyond where you are. And you're not allowed to do that. Does that make sense? It's simple, right? Okay. All right, you have the hour to do two things. That packet that I gave you, I want that whole thing done. The answers are on Schoology, so you can check that as you're going, and or work on your con. So I know, because we've done a lot more of the con now. There's one topic we haven't discussed yet. We're doing it tomorrow. And then I'm going to push the due date back till Sunday, because that's kind of mean to like teach you something Friday and then have it due Friday night. So I'll push the date back till, because some people have lives, like I don't, but I heard some other people do. So you have the hour to work on that sheet and or your con. Tomorrow we're going to finish up the chapter. I'm pushing the con back till Sunday. Questions? We good? Alexander, you alright? Did you go like a little past? So you're allowed to go like a little past. How far past?